Go ahead, Hania. So, maybe not in this order, but do you have these terms? Positive 1x. I think this should be positive 1. Oh, yeah. And then negative 2x. Do we have those terms? Yes. And then this is not the correct order. What is the correct order? Is the order not? Yes.
The correct order is negative 2x squared plus x.
So we always have to go highest exponent to lowest exponent. So highest exponent, this, we'll talk about exponents not in this unit, but this really has an exponent of 1. This doesn't have an exponent at all. So we want constants last always. That's that standard order. Yes, did you make it pass? Okay. Alright, go on first. Do we have questions about this one? Go on to the next page. Alright, so on that next page, I want you to find any problems that look complex, you want to go over together, you may be not sure where to start, any of those. Number 5. So the ones I have circled, ignore them unless that's one you want to do. Any others? Number 6. I'm going to leave 7 because it's similar to 5, and that's probably going to be the one you guys do. So we have 5, we have 6, any others?
Can you still explain again how we order them? Like, is that from this together?
It's the exponent, so highest exponent first to lowest exponent, and then when you don't have any exponents, it's variables in ABC order, and then constants. So we'll do that in a second. Alright, for number 5, it's just like we were doing on Friday. These ones with fractions and decimals, we can't really use the algebra tiles for, but other ones like these, we could use the algebra tiles, not necessarily this one because it has 2 different variables. So if you want them again, they are up here. If you'd rather do it algebraically, that's also fine. We'll use this one you have to do algebraically. So we're looking for like terms. Which ones have the same variable or has a variable and the same variable, and which ones don't?
Negative 2/3.
So that means the other 2 are also like terms. The 1/5 and the -1. So, I'm trying to remember exactly how I wanted you to do this. We're going to do this by hand, and then I'm going to show you how to do it in a calculator. So we would do the same thing we did on Friday, take the numbers in front and add them together. But can we add these like this? No. What do we have to do to one of them at least? Okay, so I heard or multiply by 2, what were you going to say? We don't have to make it a decimal. Actually, these ones are better off not being a decimal because they're repeating decimals.
Oh, okay.
But the process of multiplying by 2 makes the denominators the same, so that's what we want. To change this denominator so it's the same. But what we do to one piece of the fraction, we have to do to the other. And then when we add these fractions, we are not adding the denominators, only the numerator. So what would our new fraction become?
1/6.
1/6, yes. What's your question?
Why is 2?
We're multiplying 2 times -2.
Oh, that's a negative.
So this one was a -2, and I'm multiplying it by 2. So 1/6p. And then we're going to do the same thing to the 1/5 and the -1. So all of your whole numbers are always in a fraction form. They're always over 1. It's invisible. We don't usually see it. So if we know that this is over 1 and the denominators need to be the same, what would we multiply that fraction by so that it is now the same? 5. Because if I multiplied it by 1, this would stay the same, but this would change. Right, so then what would that new fraction be? -4/5. Then we can put those together.
So why did you divide it by, you multiplied it by 5? Like 1/1. Why didn't you multiply 5 by 1/5?
So if I multiply this by 1/1, is it going to change? No.
So you mean both numbers have to change?
Both of the denominators have to be the same. So doing this wouldn't change this one, and this one wouldn't be the same. So you both have to make them the same. Great, so your answer to that one is going to be 1/6p minus 4/5. So I want you to do it by hand, but then you can also check yourself in the calculator. So I'm sure you're going to do that really quickly. First, if you don't have your calculator, go grab that. That way we can all learn this at the same time.
My calculator is 11.
Your calculator number is... It's actually 9 because we had some skipping. Yeah, so it's actually 9. Alright, first, you're going to reset your calculator. Whatever buttons I press are going to be down here. So you're going to press second, the blue button, then plus, and then the number 712. So you're going to press second, the blue button, plus the number 712. That resets the whole calculator. Other people use the calculators. You don't want their math confusing you or anything like that, so we always reset it. And then to put in fractions, you're going to go alpha, the green button, y equals at the top. And you're going to get an option that looks like this, or a list that looks like this. You're going to choose the first one, so you can press 1 or you can press enter, it doesn't matter. Yes. I might need a battery switch, I need to go grab.
Okay.
You got it. Right, so alpha, y equals, and then 1 or enter, and you should get this fraction bar. And then we could put in the same things we just did before, which were -2/3 plus 5/6. So always use this bottom one for a negative, not this one. So this one is negative. You can press down to go to the bottom, but you have to press right to get out of the fraction. So negative 2/3 plus, and we're going to do the same thing. Go back, alpha y equals, press 1 or press enter. And then 5, go down and press 6. And then you can press enter. And it'll give you a simplified version of the answer. Right. Did anyone not get that? Okay. So, you can always reset if you want to now. Equals. The first one right there. So you need a fraction bar, then you can put in some 1 right there. Then you can put in negative at the bottom. Go down, press 3. And then go to the right. Plus. And then do it again. Alpha equals 1 or enter. And then another fraction. Okay, I'm coming up there next. You can do the same thing for the other one. So go ahead and do that. What was it? 1/5 minus 1. So alpha y equals, put in the fraction, type in 1/5, and do minus 1. Minus, not negative. And then you should get the same answer that we got. So always use this as a way to double check yourself, because this will simplify the fractions for you. You don't have to do it. All those things. Let's do number 6. What are the like terms there? Sam? Right. Remember, there is a invisible 1 there. You can add it in. You don't have to add it in. And that means the other 2 numbers are also like terms, but they're constant. So this one you could also use your calculator or do it in your head, either or. You're going to do 0.25. That's directly. Minus 1. Negative 0.75, yes. And then 1.5 minus 3.5. answer 0.75K, whoa, I missed the number there, minus 2. So it's really the same as what you were doing before. They just threw in decimals and fractions to try and trip you up. It's really the same process. So. Right. Questions on those? Try number 7. I'll give you like a minute-ish, and then we'll come back and talk about that one. Alright, I'm going to put the correct answer up, and then if we need to talk about how we got it or anything like that, then we will do that. So this should have been 2/3 cubed plus 7/12. Do we have any questions about that? Need me to do it up here? Anything like that?
Yeah.
Yes. Do it by hand or do it in the calculator?
I just want to see this.
Okay. So our like terms were these two constants and these two. So -1/6 plus 5/6. These already have a common denominator, so you don't need to change it. You just need to add the numerators. And then anytime you can simplify or reduce, you want to do that. So these can both be divided by 2. So that would be a simplified version of that. When you put it in your calculator, it will automatically give you that answer. And then you're going to do 11/12 minus 1/3. Here we do not have common denominators, so we would need to multiply this by 4. Then subtract your numerator, so we have 11 minus 4, which is 7. Keep your same denominator.
I can get the one like 1/6 plus 5/6 and the calculator.
So you got 4/6 or 2/3?
Oh, I didn't got it. I could do more.
Like you got an error message.
Yeah.
So when you put this in, make sure this is a negative, not a minus. Because you'll get an error message every single time. Alright, we're just going to do a couple more problems today. Go on to the next one. We're going to start with this one. If you want me to show you this with algebra tiles, I can do that. If you would rather this be shown algebraically, I can also do that. Does anyone want the algebra tiles version? Okay. Alright, so the algebraic version, you are taking this number and multiplying it to every number inside here. So you have to remember there's a 1 in front of the x. So we're multiplying 3 times 1, which would give us 3. And then you're just putting the x behind it. And then 3 times 2, 6. And then you just rewrite it. Questions on that one? Let's try this next one. Same thing. Multiply the 2 to all the numbers. So 2 times -1. -2x. And then not plus 1, but plus 2. Okay. Once you get the hang of this part, you don't have to write this out every time. But for now, I'm just writing it out until you get the hang of it. Let's skip the next page for the sake of time, and then go on to this one. Because I'm going to show you that there are two different ways to go about doing this. One, if you're using your order of operations, we would do grouping or parentheses first, do it inside the parentheses, and then continue. So we'll do it that way, and then we'll switch. So if we were doing what's inside the parentheses first, we would need to combine our like terms. So on the inside of our parentheses, we have 2 times negative x minus x. How many x's would that be?
Negative 2.
Negative 2x, 3 plus 2, 6 plus.
Oh,
So we would combine those first, and then we could distribute. So multiply 2 times negative 2 and 2 times 5. What would that be?
Negative 4x plus 1.
So negative 4x plus 10. 2 times negative 2, 2 times 5. You could also, so I'm going to do this way down here. Let's say I had this same thing, I'll rewrite. And now, let's say I forgot about my order of operations, and I wanted to distribute first. I'm going to distribute the 2 to every single thing. Multiply 2 to every single thing. So this would be negative 2x plus 6 minus 2x plus 4. But then I would still need to combine my like terms. What would we get? Negative 4x plus 7. So we would get the same thing either way, as long as you still do both operations. Now when we get to evaluating, the order matters. But here, whether you distribute first and then combine like terms, or combine like terms then distribute, it does not matter. Questions on that one? Alright, this will be our last one for today.
Can you go back up to the
Yes.
numbers up there?
Make sure you guys are paying attention, not talking.
Or not, actually, just because we got, well, I'm.
So then what would be our first step?
3 times negative 2.
So 3 times negative 2 would give us negative 6x. 3 times negative 1, negative 3, or minus 3 in this case. Then we just bring down this plus 4x. What would be our last step?
Minus 6x plus 4.
And what would we get?
Negative 2x.
So we're going to do more with this tomorrow. More examples, a little bit harder examples, and then some more practice. Tomorrow we also have a fire drill, but pretty sure it's supposed to rain tomorrow, so if it gets canceled, we'll talk about it. This period, like towards the end, yes. So we are done for today. You can put your calculators up. Oh, really quickly before you do that. I did put in your delta math, so don't pack up right now. Wait, listen. Everyone sit, listen. I did put in your delta math scores. If you did not do that / did not join, it is now missing. You need to do that and email me that you did it, so that way I can update your grade. There is another one due on Thursday on simplifying expressions. Some of you have already started that. Some of you could start it, get it done.